7 Solar System Myths. Have you been tricked too? Welcome back to our journey through the most shocking misconceptions about our solar system. After demolishing 7 of your certainties about the Sun and inner planets in the previous video, today we're going further: the Moon, which you think you know, and the giants of the outer solar system. Get ready to discover that even our most familiar satellite hides incredible surprises, and that what you know about the giant planets is often completely wrong. Our brains keep looking for simple explanations, while the universe enjoys proving us wrong with its infinite creativity. 7. The Sun doesn't rotate on its axis. The Sun doesn't rotate on its axis. Here's a misconception that seems so obvious it's rarely questioned. The Sun is the fixed center of the solar system, the immobile point around which everything orbits. It's the great stationary star that illuminates the dancing planets. Logical to think it's still like the center pin of a carousel, right? Completely wrong. The Sun rotates on its axis, and it does so in a rather exotic way. It's not a rigid rotation like that of a rocky planet, but a differential rotation that makes our Earth seem fluid. The Sun completes one rotation at the equator in about 25 Earth days, but at the poles it takes about 35 days. It's like it's made of jelly spinning at different speeds depending on latitude. This happens because the Sun isn't a solid ball but a gigantic sphere of plasma in continuous convective motion. But how do we know this, if the Sun is a blinding ball of light with no visible fixed features? Ingenious. Astronomers observe sunspots, temporarily darker areas on the solar surface caused by intense magnetic fields. By following the movement of these spots, we can precisely measure solar rotation. Solar rotation isn't just an academic curiosity, it has important effects on the entire solar system. The movement of solar plasma generates the Sun's magnetic field through a process called the solar dynamo. This magnetic field extends into space, forming the heliosphere, a gigantic magnetic bubble that encloses the entire solar system and protects us from some cosmic radiation. The Sun's differential rotation is also responsible for the 11-year sunspot cycle. Magnetic field lines get twisted due to different rotation speeds, periodically creating unstable configurations that result in sunspots, flares, and magnetic storms. So next time you look at the Sun, never directly, remember you're not watching a fixed lantern hanging in the sky, but a gigantic plasma top that spins, twists, generates magnetic fields, and drags us all on an epic journey through the galaxy. So much for an immobile center. 6. Lunar phases are caused by Earth's shadow. Lunar phases are caused by Earth's shadow. There are quite a few people who believe that lunar phases are created by Earth's shadow projected onto the Moon. Others even think, can you believe it, that the Moon changes shape because of clouds. The reality is much simpler and more fascinating. The Moon orbits around Earth in about 29.5 days. During this orbit, it continuously changes its relative position with respect to the Sun and our planet. We always see the half of the Moon facing the Sun illuminated, but depending on the orbital geometry between Earth and Moon, the entire illuminated lunar hemisphere can appear increasingly reduced, from quarter moon to new moon, passing through the thinnest crescent. It's like illuminating a ball with a flashlight. The half facing the flashlight is always lit, but if you move around the ball, you'll see more or less of the illuminated part depending on your position. Earth's shadow only comes into play during lunar eclipses, rare events that happen when Earth, Sun, and Moon are perfectly aligned. During a lunar eclipse, the Moon actually passes through Earth's shadow and temporarily darkens. But normal monthly phases are just a matter of geometry and perspective. 5. The Moon doesn't rotate on its axis. The Moon doesn't rotate on its axis. The Moon always shows us the same face, so it doesn't rotate. This is a misconception that fools even many educated people. It seems logical. If it rotated, we should see different sides over time, right? Actually, the Moon rotates big time, but it has perfect synchronous rotation with its orbit. It takes exactly 27.3 days both to rotate on itself and to orbit around Earth. That's why we always see the same face. This synchronization isn't a cosmic coincidence, but the result of billions of years of gravitational interactions called tidal forces. Initially the Moon rotated much faster, but Earth's gravity gradually braked its rotation until it synchronized with the orbit. The same phenomenon has locked almost all major moons in the solar system relative to their planets. Io, Europa, Ganymede, and Callisto always show the same face to Jupiter. Titan does the same with Saturn. It's the rule, not the exception. That said, seeing the same face in the sky all the time, it's obvious that quite a few people continue to believe that the Moon lacks its own rotational motion. But without getting too technical, a simple thought experiment will debunk this belief. Imagine being in a crowded room, with you at the center and a person looking at you while walking around you. It will seem to you that your partner isn't rotating because you'll keep seeing their face motionless relative to you, but other people around would see their head turn and successively show all its sides. The back of the head, left ear, face, right ear, back of the head again, etc. The moon, in short, stays still for us, but the rest of the universe knows things aren't really like that. Hey, curious? Before moving on / answering the question, be sure to subscribe to our channel clicking on the notification bell, and leave us a thumbs up, so you don't miss out on our daily videos. 4. The moon influences human behavior. The poetic lunar influence. How many times have you heard that during a full moon, people become more aggressive, more babies are born, crime increases, or psychiatric patients get worse? The term lunatic wasn't born by chance, and even today many people are convinced the moon has profound effects on human behavior. 2 decades of rigorous scientific studies have shown that there's no statistically significant correlation. Zero. Nada. Nothing at all. But wait, you'll say the moon influences tides. If it can move entire oceans, why shouldn't it influence the human body that's 60% water? Seems logical, right? The problem is that the lunar tidal effect depends on the size of the object involved. Oceans are enormous, thousands of miles in extent, so even a small force applied to such a large mass can create visible effects, tides precisely. The human body is microscopic on an astronomical scale, and the moon's gravitational effect on you is weaker than that of a bus passing on the street. Moreover, the tidal effect doesn't just depend on the moon's presence, but on the difference in gravitational attraction between different points. There are no tides in a glass of water because all points in the glass are practically the same distance from the moon. The same goes for your body. Epidemiological studies have analyzed millions of data points: hospital births, police arrests, psychiatric admissions, traffic accidents, suicides. No correlation with lunar phases. The data are clear. A full moon doesn't increase crime, doesn't make more women give birth, doesn't worsen mental disorders. So why is this belief so persistent? Dark literature and confirmation bias. When something strange happens during a full moon, we notice and remember it. When the same thing happens during a new moon or first quarter, we don't pay attention. Our brains are programmed to find patterns even where they don't exist. The moon is beautiful, romantic, fascinating, but it's not the puppeteer of human behavior. We are responsible for our actions, not our satellite. 3. Crossing the asteroid belt is extremely dangerous. Science fiction movies. How many times have we seen spaceships frantically zigzagging between giant asteroids, constantly colliding, pilots sweating bullets while avoiding space rocks by a hair, spectacular explosions when a spacecraft gets hit by a meteorite? Hollywood's asteroid belt is a super-dense minefield, a nightmare for any pilot, a place where only spaceflight aces can survive. It's the cosmic equivalent of driving blindfolded in a hailstorm made of boulders. The reality? The asteroid belt is empty. Almost completely empty. It's so sparse that if you randomly launched a probe into it, the chances of hitting an asteroid would be similar to winning the lottery while being struck by lightning during a solar eclipse. The asteroid belt extends between Mars and Jupiter, in an enormous region of space. We're talking millions and millions of cubic miles. Within this immense volume roam about 1.1 to 1.9 million asteroids with diameters larger than 0.6 miles, 1 kilometer, and millions of smaller objects. Sounds like a lot, right? But let's do the math. If you uniformly distributed all these asteroids in the belt's volume, the average distance between one significant-sized asteroid and the next would be hundreds of thousands of miles. It's like putting 2 grains of sand on opposite sides of a football field and saying the field is full of sand. The space probes that have crossed the asteroid belt, Pioneer 10 and 11, Voyager 1 and 2, Galileo, Cassini, New Horizons, and many others, have never had traffic problems. They didn't have to make evasive maneuvers, didn't turn on defense systems, didn't dodge rocks by a whisker. They crossed the region without even realizing they were in the fearsome asteroid belt. So why this perception of mortal danger? Blame cinematic representations that compress immense spaces into dramatic shots. It's much more spectacular to show rocks colliding every second than the boring reality of nearly empty space. 2. Saturn is the only planet with rings. Saturn and its magnificent rings are probably the most iconic image of the solar system after Earth seen from space. When you think of planets with rings, it's natural to think only of Saturn. It's the star, the most photogenic planet, the one that makes even kids go wow. But here's the surprise. All 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, are surrounded by ring systems. Saturn is just the one that shows them off best, like a diva who knows how to pose for photos. Jupiter's rings were discovered in 1979 by Voyager 1. A totally unexpected discovery. They're very thin and composed mainly of dark dust, probably debris expelled from its small inner moons when hit by meteorites. They're so faint it's almost impossible to see them from Earth even with powerful telescopes. Uranus has a system of thin, dark rings, discovered in 1977 during a stellar occultation. Astronomers were observing from a flying airplane a star that would pass behind Uranus when they noticed the starlight dimming and brightening rhythmically before and after the planet's own occultation. There was surprise, but eventually the astronomers surrendered to the evidence. They were 13 rings, barely luminous and only a few miles wide. Neptune has even thinner and harder to see rings, discovered in 1989 by Voyager 2. Some are so irregular they look more like arcs than complete rings, probably held in position by the gravity of its moons. But why does Saturn look so good compared to the others? First, its rings are enormous. They extend for hundreds of thousands of miles but are only tens of yards thick. Second, they're composed mainly of water ice, which reflects sunlight very well. Third, they're incredibly dense and structured, with thousands of concentric rings separated by divisions created by the gravity of its moons. But next time you look at Saturn in a photo or through a telescope, remember it's not the only married planet, it just has the most flashy wedding ring. 1. Saturn's rings are solid. Looking at beautiful photographs of Saturn, it's easy to think its rings must be solid and compact, like a giant CD spinning around the planet. It's natural to imagine them this way, smooth, uniform surfaces you could theoretically walk on, if only you could get there. The reality is completely different. The rings are composed of billions and billions of separate particles, from tiny dust grains to boulders as big as houses, all orbiting independently around the planet. The whole thing is more like a swarm of bees than a solid disk. If you could fly through Saturn's rings with a spacecraft, something already experienced by the Cassini probe, you wouldn't have the sensation of crashing into a solid wall. It would be more like flying through very thick snowfall, a continuous bombardment of icy particles of all sizes traveling at orbital speeds of tens of thousands of mph. But then why do the rings appear so solid and defined in photos? It's an optical effect. When you look at the rings edge-on from Earth or space probes, you see billions of particles all together, like when you look at a cloud that seems compact but is made of separate water droplets. The rings have incredibly complex structures. Divisions, undulations, radial spokes that appear and disappear, concentric rings with different densities. All this is caused by complex gravitational interactions with Saturn's moons, which act as shepherds, pushing and pulling ring particles into ever-changing configurations. Some moons orbit right within the rings, creating gaps and density waves. It's like having cosmic traffic cops directing the flow of billions of particles in gravitational dances of mind-boggling complexity. If the rings were really solid, they would have been destroyed by the planet's tidal forces long ago. It's precisely because they're composed of separate particles that they can exist and be so dynamic and beautiful. Nature prefers chaotic dance to rigidity. Conclusion. Okay guys, here we are at the end of our second journey through planetary misconceptions. And we still have 3 more videos to explore. But don't worry, the solar system is an inexhaustible mine of surprises and wonders just waiting to be told. Is there anything you don't understand about what we've told you? So, let us know in the comments. And if you want to learn more about the solar system, check out the whole series we've dedicated to it, planet by planet, or check out other videos on our end screens to learn more.